Right, more of a sort of a fun than a specific tech. I'm going to do Advent of Code. It's something I'm very fond of myself. So, this is me. I'm Peter Gillett. That's my GitHub. If you want to see any of my previous Advent of Code solutions, they're all on there. Let's crack on. So, what is Advent of Code? It's based on an Advent calendar. So, there's going to be 25 events on it. Each day is a puzzle, so it's just going to set you some coding task. The puzzles usually follow a story. It's usually a Christmas theme, so it's elves and Santa and things and delivering presents and all the problems which come from that. Each puzzle is split into two parts, and you're supplied with your own test data for the puzzle. And you have to provide an answer. So the only thing you have to do to complete it is provide the answer. As you answer one part of the puzzle, you then get the second part of the puzzle will open. There's no restrictions on how you solve it. If you can do it in your head, you can just put the number into the site. Probably can't, but you can use any language. You're not submitting code. You're just submitting answers to play. You just need a GitHub, Google, Twitter, Reddit login to play. And it's now been running for 8 years, so it's been running since 2015. There's a scoring and leaderboard on it. The puzzles are released every night at midnight EST, so that's 5 AM UK. And then points are awarded based on completion time, so everybody starts them at the same time, and you're awarded points based on that. The 100 points go to the first place, and it's down to 1 point for the 100th place. The first few puzzles on the first day, you'll look at the leaderboard and they will complete in minutes. Literally before you've had time to read what the question is, someone will have done it. So it's pretty hardcore on the leaderboard. And then as you get further through, you'll find that even the top players can take 20 minutes to complete a puzzle, and a lot of them are a good hour. At last check, I think it's now 250,000, but 250,000 people completed part 1 of day 1. This is 2021 that we're doing, and 11,000 people completed part 25. They do get harder and people do drop out. It is addictive and it is time consuming, I will admit. As you see here with our graph, we have our pros, so that's the people on the leaderboard, the green line at the bottom. This is our mere mortals, us lot, on the blue line, and you'll see as you get forwards through the month, you'll be doing more Advent of Code and less work. And there are some stories of people who've done quite a lot less work that myself and Kev know. Right, so 2021, this is the introduction now. You're minding your own business on a ship at sea when the overboard alarm goes off. You rush to see if you can help. Apparently, one of the elves tripped and accidentally sent the sleigh keys flying into the ocean. So before you know it, you're inside a submarine. The elves keep ready for situations like this. It's covered in Christmas lights, of course it is, and it has an experimental antenna that should be able to track the keys if you can boost its signal strength high enough. There's a little meter that indicates the antenna's signal strength by displaying 0 to 50 stars. Your instincts tell you that in order to save Christmas, you'll need to get all 50 stars by December the 25th. And you get collecting stars by solving puzzles. 2 puzzles made available each day. Second puzzle is unlocked when you complete the first, I was saying earlier, and each puzzle grants a star. If you can't get the second star, the second star is usually a bit of a twist. If you can't get the second star, you can move on to the next day. Once that puzzle's available. And obviously you can go back and complete them retrospectively. So, day 1 is called Sonar Sweep. As the submarine drops below the surface of the ocean, it automatically performs a sonar sweep of the nearby seafloor. On a small screen, the Sonar Sweep report, your puzzle input, appears. Each line is a measurement of the seafloor depth as the sweep looks further and further away from the submarine. Suppose you had the following report, so a set of numbers. That report indicates that scanning outwards from the submarine, the sonar sweep found depths of those numbers, so 199, then down to 200 and 208. So the first order of business is to figure out how quickly the depth increases, just so you know what you're dealing with. You never know if the keys will get carried into deeper water by an ocean current or a fish or something. To do this, we need to, and this is, I don't know whether you can see that it's bold, there's a little bit bold there that says count the number of times a depth measurement increases. And this is quite common with advent code. It will bold the bits that, most of its story, it will bold the bits that are important. So, and there's no measurement before the first measurement, so we're starting from the second one. So in that above example, there's our measurements. So the second one at 200, that's increased, then increased again, increased, then decreased, increased, increased, and so on. So in that example, there are 7 measurements that are larger than the previous measurement. So the answer is 7. So how many measurements are larger than the previous measurement? So this is where we get our test data, and we now need to run our bit of code on our test data and submit the answer back to the website. So if I just flick to some code, there's our test. So I've put this test input in there because we know that the result for the test input is 7 because they've just told us. So that gives us something to work from. And we've got another set of test input there, which are actual puzzle inputs. And you can see there's like loads of values in it. So you've got to write code really. So how do we do that? So should be quite straightforward, this. Most people should pick that up and be able to work through. We break that list down into an array of integers. We need to check each item with the item before and then count it if it's greater. We'll start from the second one because they've told us there's not a figure for how it's changed on the first one. So we'll start from number 1 or position 1 in the array. And then we'll compare with the previous item, so n minus 1. And we'll add 1 to the counter if greater, and we repeat until the end of the array. I think that's the end of that. Right, so I'm going to be daring and actually code. And even though I've done this several times, sometimes it does go wrong. So we will take, let's, I think I called it count, didn't I? Count. So we'll get our input, can't type, get our input. Let's go and have a look at our test. What's in our test? Did I call it count? Oh, change. There we go. So day 1, we called that the change. Right, so we split it up into an array of integers. Yeah, go on. Can you make the font bigger? Oh yeah, sorry, yeah. How much bigger? Is that right? Yeah. Okay, so we're going to take, we know they're all on new lines, so let's take the input, split it by environment new line, and then we'll select and we'll int past that and then convert that into an array. So that's the step. That's step 1, break the data into an array of integers. So we need to check the item with the one before, increase counter greater, start from n, compare it to n minus 1. Okay, that's not too bad. So let's do a count, and then we'll, for n equals 1 to n is less than split dot length, n plus. And then we can do if, what do we call them, depths? Do I call them depths? No, I call them split. Let's call them depths. Let's change that. Depths. N is greater than depths. Depths. Come on, n minus 1. Then we'll increase our count and we'll return our count. And where have my unit tests gone? What is it? Unit tests. Oh, where have they gone? Come on. Am I missing them somewhere? Is that because I've made it bigger? Oh, there they are. Sorry. Right, and let's run those. And if they run, our day 1 tests. Come on, day 1 test. So we've got our test. The test data came out at 7. I know from having done it before that the actual answer will be 1, 2, 3, 3. But if we ran that then on our puzzle data, we could then put the 1, 2, 3, 3 into the website and it'll let us carry on and give us our star. Okay, so that's how they start. So that's part one, and then part two will follow up. Considering every single measurement isn't as useful as you expected, there's just too much noise in the data. So instead, consider sums of a 3-measurement sliding window. Again, considering the above example, we start by comparing the first and second 3-measurement windows. The measurements in the first window are marked A, so that's 199, 200, and 208. So there's sum 607. The second window is marked B, so 200, 208, and 210, and its sum is 618. The sum of the measurements in the second window is larger than the sum of the first, so this first comparison increased. So that's where we're going. Your goal now is to count the number of times the sum of measurements in the sliding window increases from the previous sum. So compare A with B, then compare B with C, and then D with C with D, and so on, and stop when there aren't enough measurements left to create a new 3-measurement sum. So, still quite straightforward, but sometimes you find that your solution in the first part, you assume that you'll just adapt your solution in the first part, and sometimes you can adapt it. Quite often it's a bit of a red herring and throws you. So in this one, we've got A at 607, and then 618, 618, and so on. And in this example, there are 5 sums that are larger than the previous sum. So considering sums of 3-measurement sliding window, how many sums are larger than the previous sum? So let's go through that again. So break the data into an array of integers, that's fine. Now we're comparing the sum of n plus 1, n plus 2 against n plus 1, n plus 2, n plus 3, added together. So if we do the same way as we did first time, so we didn't have a first measurement, so we started from the second. So now if we start from the fourth, we can work backwards. So the first number is n minus 3, minus 2, and minus 1, which is, so if we start on that one there, we've got minus 3, minus 2, and minus 1. And the second should be minus 2, minus 1, and n. We can compare them again and increase our count if greater and repeat to the end of the array. Let's come back to that bit. So let's go to our test. What have we got? Group change. Not used to seeing it this big now. So we're going to have a change. We've called it change 3. So let's do that. Public int change 3 string input. I think we can probably copy most of that, as most of it should be the same. Let's pop that there. And then in this bit, we're saying we need to start from n3. And then we're going to say the first item is depths n minus 3 plus depths n minus 2. I'm just going to move that over a bit. Let's have a bit more room. Plus depths n minus 1. And the second is depths n plus depths n minus 2. Let's just do it the same way. So minus 2, minus 1, and n. Okay. And then we're going to compare the second with the first. And if that's okay, we'll count plus plus. Okay, so we can take that bit out. And if we go back to our tests, hopefully, hey, so that went well. So we can leave it there. Quite often, when you get into Advent code, you tend not to leave it there. You tend to start refactoring it, because we can start working out that this is basically the same bit of code. So we could bring in here and put the interval in there. Then we could put the interval in there. Interval, I did call it interval. Interval, yeah, interval, just catch up. Oh, no, sorry, go back, missed a bit. So what I was going to say was, so we repeat to the end of the array. Yeah, when you start refactoring, you start spotting things where you can clean this up. So we're comparing 210 plus 208 plus 200 with 208, 200, and 199. Maths will tell you that that's the same as comparing 210 with 199, because you've got the 208 and the 200 on both sides. So you can come back to the code here, and our actual code can now be that and that. And I'm pretty sure, won't work because I put that in there. Let's get that out. If we run that, and it still works, so that's good. So now we can see that we've got an interval. So if I put that, let's go change, and we'll put and pass a 3 into there, and then we'll put a new method in here, string input and int interval, and we should now be able to take the interval and replace that there, try again, replace that there, and then this code, we can get rid of this code as well, because that's the same thing, and that's the change with the input and 1. And we'll just run that. If I make any glaring mistakes, shout out. I don't really want to do a debugging session. And you get into that sort of habit, and once you get a few discussions going on between people, your tendency will be to trim that down, see if you can get it into one line of link or something like that. There's a fair old challenge, and it's good for your brain, I suppose. Right, I'm going to leave that one there and move on a bit. It took me a while to decide which item to do next. Oh, that was that compare. But I'm going to do day 14. The reason I picked day 14 is because it's complicated but not a big solution. Some of them you write a fair chunk of code to actually solve them, but this one's reasonably complicated, but it's fairly compact. So, the incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. Okay. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, which is your puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. Okay, a little bit more complicated now. For example, the first line is the polymer template, so NNCB. This is the starting point of the process. The following section defines the pair of insertion rules. A rule like AB to C means that when elements A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. So starting with the polymer template NNCB, the first step simultaneously considers all 3 pairs. So the first pair, NN, matches the NN to C rule. So element C is inserted between the first N and the second N. Okay? Are we following this? The second pair, NC, matches the NC to B rule, so B is inserted between the N and the C. And finally, the third pair, CB, matches the CB to H rule, so H is inserted between the C and the B. So, note that the pairs overlap, so the second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of the pair until the next step. So what it's saying, as we're inserting them, we need to ignore that new pair as we move on. So, after the first step of this process, the polymer becomes NCNBCHB, okay? And here are some more steps using the rules. So it goes from there to there, to there, to there, to there. Okay, so it gets quite big. If I jump into the code again, day 14 test, so that's the example one, and our actual test one has got a lot more bits in it. Obviously, when you start debugging, that tends to make it quite hard to follow what's going on sometimes. But tests are your friend. Let's just take those. That's fine, and I call it score. Okay, so. How are we going to solve this? So the polymer grows quickly. After step 5, it has length 97. After step 10, it has length 3073. After step 10, B occurs. 1,749 times, C occurs 298 times, H occurs 161 times, and N 865 times. So taking the quantity of the most common element and subtracting the quantity of the least common element produces 1588. So apply 10 steps of pair insertions to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, this is why I said this was a little bit more involved than the previous one. And they do get like this, and sometimes you read them and you think, I really don't understand what it's asking me to do. But most of the time, persevere. You can work it out. Quite often, if it gets complicated, they'll give you in between stages. So although they've told us what the answer is for 10 steps, they've also told us what the polymer should be at each step. So we can put a test in and say, let's do one step and see if we get that. Let's do 2 steps, see if we get that. So you can test it and debug it in a much more compact environment. Right, so how are we going to do this? So let's break the data into a template and rule set. That's pretty standard with all the tests, with all the puzzles. We can break it on this gap here. That will give us the template and the list of rules. Then we'll take the list of rules and set up a dictionary. So put the rules on one side, put the insertions on the other side. That doesn't sound too bad. So now we need to run through the template character by character and select a pair. So as we go from 0, take character 0 and 1, move to the next one, 1 and 2, and so on. Look up the matching rule, and then insert that rule character between that pair, in that string. That sounds all right. Move 2 places forwards, because otherwise we're going to pick up the new character that we've inserted. So we need to go 2 places forwards. And then repeat that until we get to the end of the template. So that would be the solution for the first test. So if you want to do a test, you could do a solution there. And then repeat that for the number of iterations. Okay. I think that's... And count the number of occurrences of each character, and find the lowest occurrence and highest occurrence, and subtract the count of each. Right, that's it, yeah. Okay. Let's code that. This is where it could go wrong. What did I call it? Score. Don't know why I called it score, but score will do. So let's take our input. Let's split the input by, I'm going to do it by a double new line because that was that gap in the middle. Most of it tends not to have extra spaces or anything like that, so you can just detect new lines and things. So our template, we know, is the first item in that split, so the first half. And then we need the rules, and we said we were going to create a dictionary from the rules. So we're going to take the second set, split that up by new line. So environment new line. And then we're going to convert it to a dictionary, and on one side we're going to take the 2 characters. So we're going to take the first 2 characters and then take the last character for the other half of the rule. So that's one half of it, and then on the other half, let's take the last character. Okay. So that's our rules. Next step, we said we're going to run through the template character by character, but we're going to step by 2. Let's get the iterations going. So we're going to do this 10 times. And then we said we're going to move character by character. So is less than template length. We're going to have to go template length -1, because otherwise we won't get the last pair, or we'll overrun. And we're going to do C plus 2. And then we can get the pair out of that string. So the pair is template, substring, position for C for 2. That's all right. Look that up in the rules. So get our insertion is the rules pair. and then we need to piece our string back together. So I'm going to take the first C+1 characters, so C+1, then I'm going to add the insertion, then I'm going to add the rest of the string. Okay, substring from C+1. I think that's all right. So that runs through the template, and that runs through the whole thing 10 times. So when we've finished, we need to work out what the frequency of each letter is. So let's take the template, let's take each character, then group it by character. Yeah, that's right, isn't it? Group by character. Then we want to select the group, take the group key and the group count, don't we? So we need to see how many each key and then do the count of each letter. Oops, missing a bracket. Stick that in array. No, let's go a step above. We're going to sort that, so order that by. So if our pair, item 2 is, so if I go there, the count is item 2, so let's order it by item 2 so we can see which is the most popular and which is the least popular. And let's return letters last, item 2 count minus letters first, item 2. I think that's right. Let's run it. Yay! That wasn't bad. Right. So, everyone following it so far? Yeah? Yeah, we're all right. So that's part 1. Part 2. The resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process. A total of 40 steps should do it. Okay, it sounds fairly straightforward. In the above example, the most common element is B, occurring about 2 trillion times, and the least common is A. I can see it going a bit wrong now. Apply 40 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? So we'll just do it again, but we'll just run it through 40 times. Sounds fair enough? You're not going to do that because we don't have the processing power or the memory. You're going to need 2 terabytes just to hold the B's. So we're going to have to do something else. And this is classic advent of code, that you think you've got a nice solution, you refactor it, you've put some variables in it so you can apply it for the next bit, because you know what's coming up. And then they do this. And it usually moves into infinites and just things which are too big to handle, or brute force. Occasionally you can brute force them if you optimize them enough. So, solution 2. So the initial data with a string at each iteration. So it's told us about the string at each iteration, so we've done that, but I think that's a complete red herring because we can't store the string. So what are we trying to do? We're trying to count the number of characters at the end of the processing. So that's all we really want. We're not bothered about the order that these characters are in the string. That doesn't matter at all. We can't store it as characters with their counts because we need the pairs, because the pairs drive the rules. So we need to store the answer or the workings as pairs and the counts of each pair. So if we've got something like NN, CB, NN, what we've got is 2 NNs, an NC, a CB, and a BN. If we go through to step 1, so we'll go for the first one, we're saying that NN, so NN inserts a C. So what we'd end up with is NC, NC, BN, CN. we haven't got any NNs in them anymore, so we can take the two NNs that we've modified away. So now we've got naught NNs, we've got an NC, a CB, and a BN. And then, because we've had two NNs, we now have two NCs and two CNs. Okay? So if we keep track of those pairs, we can work out what's going on. And all we need to do is for each pair that we've got, check how many there are, which we're going to keep in a dictionary or something, then find the replacement and add those two pairs with the same quantity. Okay? And then when we count it, we've got to remember only to count the first character, because the second character of the pair is in the next pair as well. Otherwise, we're going to count things twice. Okay, which is what that says. So count the first character of each pair. Okay, that's it. Right. So this will be a bit more fun. So I am going to start by just, what do they call it? Score 40. Right, let's go back to there. Let me give myself a bit more code window to play with. So we'll take that, copy it, and let's see what we can do. Score 40. So the split's all right, that's fine. The template's right, we're still going to work with the same template, and I think the rules are okay as well. None of that's going to change. So we need a count of the pairs. So probably the easiest way of doing that is to set up my counts and use the rules as a starting point. So create another dictionary, take the rule and take the rule key, and then stick a 0. Yeah, that's a good point. Change that to a long, because we know that's going to be a long when it comes back. So we're going to create a set of counts, and we're going to set them all to 0. Then we could go through our... does it help? That'll help, won't it? We can go through our template, so start at 0, go to C is less than template length -1, because we're going to do C and C plus 1. Step through that, and we can then put into the counts template substring C for 2, and we can just do an add on there. Right. So we've now got a starting point. So we've got a starting point with how many of each pair we've got in the template. So next step, let's do it 40 times. And we're going to need a result set. So if we want to process that set of counts, we can't be changing that counts on the fly whilst we're trying to work through it. So let's copy it and get a result set and then reuse that each time. So let's take results equals new dictionary of string and long, and we'll copy that from counts. Okay, and then we're going to go through each key value pair in our counts. And what we need to do is take that pair and the number of that pair, look that pair up, find the insertion, build our two new pairs, and add the two new pairs to our result set and take the first one off. So, pair. So that's key value pair dot key, and the number of them will be our key value pair dot value. That's fine. So we need our insertion, which is the rules based on that pair. And then we can build our two new pairs. So pair 1 will be the key, move away, come on, out of the way, is the pair, first character of the pair plus the insertion. So that's 1. And our other pair will be the insertion plus the second character of the pair. Okay, all making sense? So in our result set for our original pair, we can now subtract the number of that pair, how many there were, and we can then pair 1, we can add the number, and results pair 2, we can add the number of those as well. So that will create us a nice set of new results at the end of the key value, end of the values in counts, and then we can replace counts with the new results. Okay, and we can get rid of that code. That's right, yeah, and that's the end of the iterations, yeah. Okay, so letters. How do we get the letters out? So we want to take the counts, and we said we only need to take the first character of each one, and then we can count that up. So let's group that by it's the key value pair, key, first character. Okay. Then we can, let's take that out. And then when we've got that, so we've now got lots of the first characters and lots of occurrences, plus the number of each of those occurrences as well. So we might have the A from AA and the A from AB, and from AA we'll have a number on there and a number on the AB, so we need to total those up. So if we select the key and then we count, we sum the number of items on each of those pairs, on how many brackets? One less, is that right? It's G dot sum. So group by select. That's right, surely. Item 2. What have I got wrong? Group. Counts. I refuse to look at my code. So we group it by key 0, that's fine. And then we select from that group and we get the group key and the group sum of the key value pair. Well, that should be item 2. Surely that's item 2. Oh no, it's value, sorry. Okay. And then we order it again by item 2 to get them in order, and then we do it to an array, and we get our letters first and last. And if we go to our tests, we should be able to run those, hopefully. And we get things like that. So we expect the result to be 236029889577, but we got 23602988957778. So something's not quite right. I think we've got it pretty much right because it's close enough, but it's not the right answer. And these things sometimes confuse you a bit, and you think, why? I've done it, it's working, why is it not working? So what's gone wrong? So that was our code. That was our earlier sample, and we said that's an NCC and NCCB, BN, NC, and CN. So there's 3 of those, one of those, and 2 of those. So when counting, we don't count the second character because it's always counted as the first character of the next pair. So if we count the first character of each pair, we've got 3 N's, a C, a B, and 2 C's. So that comes to 3 N's, 3 C's, and a B, which is 7 characters. But that original string is 8 characters. There are 4 N's in that string, not 3 that we've got. And that's because the last N doesn't form the part of another pair. So we're missing that from our count. So we just need to stick that on. So let's pop that in here. So if we go to our counts and we set template, last character of template, and a dash, so we don't need anything, and a dash, and we'll set that to be 1, and then we'll run it again, And there you go, we've done it. Now things like that, you can then go back, refactor those. There's quite a lot of fun that you can have refactoring that one. If you want to know how far it will refactor, it will refactor to that. So you can split the input up, get the rules, and then you can generate the list of letters in one link statement. It's not the easiest link statement to read. We're going to take a range of 0 to 40. We're going to take the original template, zip it with the same template but one step forwards to get a pair. We're going to then build that pair into our list and put a 1 in for theirs, group them up. Then we're going to aggregate that, and for each one we're going to get a new array with the two new pairs in it. Stick that all together. We have to regroup that because otherwise, just the same as the string would grow too long, that list would grow too long as well. So we group that back up, then we select them back out, concatenate our one individual item from the last character, group it, and then that's back as it was, and that will give us the first and last. And there's all sorts of challenges where people will benchmark them and compare benchmarks for them. You can get some massive differences depending on what language people are using, or to be able to benchmark them and look at the memory they use, and sorting some solution without actually allocating memory and stuff, which if you think of our first solution would allocate quite a lot of garbage doing those strings. So final thoughts, give it a go. It's there's no pressure for it. You can dive in, do a few days and say it's not for me, or pick it up later in the month. As I say, it is time consuming. I try and get mine done early in the morning before I get on with my work, but you're often picking them up at lunchtime and weekends and things like that. It's a good challenge. And if you are interested in doing it, on .NET York, there's a private leaderboard and there's private discussion groups as well. So if you don't feel like discussing your solution on Reddit with the pros, then there is a friendly private group that will discuss and pass. We generally say don't put your solutions on if you've solved it. Let's discuss it until everybody knows what they're doing. But that's it. As I said at the start, if you want to see my solutions, they're on there. I've done 3 years or something. I think I've done. I keep meaning to go back and do some more when I've got time. But, yeah. Thank you very much. I assume there's not going to be, unless there's any questions, but it's not. No. Does anybody do it just out of interest? Good. Excellent. Were you going to ask a question?
Yeah, I was. How long has it taken to do one of these? Like, what's the hardest thing you've ever done?
I've spent all Sunday on one before. Yeah, just backwards and forwards with one of the guys that runs .NET York. No, he tends to do like a couple of hours, and then you just have to come away from it because you're just struggling. C#'s not bad. I mean, if you can move into C or something, you can brute force a few of them. And when you start getting a solution and I sound off with somebody who does it in Python, and I say, it's a bit frustrating because it's now taking 50 seconds to actually run the puzzle, and he says it's taking mine 50 minutes to run the same thing in Python. And then a little bit of optimization, you've got that 50 seconds down to 5 seconds, and then you just spot something where the the key thing that you're missing, and then suddenly it's instant because you've got the code. There's a lot of coding. Like algorithms, so there's some fairly standard algorithms that if you know your algorithms, you'll get through these quite straightforward. If you don't know your algorithms, this is quite a good way of learning them because you're forced to learn them because you won't solve them without them. Okay, yeah. Yes, yeah. Well, I mean, you can, but you're only cheating yourself. That's it. Don't submit them. No, that's it. But what amazes me with it is the fact that everybody gets a different puzzle input. So you can't get somebody else's answer and submit it. If you really can't do it, you can't just get somebody else's answer and submit it on yours. It doesn't work. And it amazes me that they can generate these puzzles and generate, I don't know how unique it is or whether there's a batch of 50 or something that gets scattered around, but the fact that they can generate data that works for each puzzle as well. It's somebody puts a lot of time into it. Okay, thanks very much.